Welcome to the project demonstration of SEPIC converter with inverter fed AC motor. So here we are controlling this AC motor with the help of a SEPIC converter. So in order to control the speed of this one, we are going to measuring the speed with IR sensor, and we are placed one black and white for reflection based on the motor shaft. From here we are going to measuring the speed of this AC motor, and from here we are going to set the speed for this induction motor, and based on this inputs my microcontroller will control the SEPIC converter in order to boost or buck the output voltage, and that was given to the inverter circuits, and from here we are going to drive the AC induction motor. So let us see the components wise explanation. So here, so the flow is like so. From this adapter we are going to provide the 5 volts power supply to the circuits directly, because the microcontroller work under the 5 volts power supply. And once we provide the 5 volts power supply to the microcontroller, so here, so it will start reading input from the input module like potentiometer. So in order to increase and decreasing the speed, so initially I'm placing it in 0 position, and another input module is IR sensor to measure the speed of this AC induction motor, and the output modules are two, like LCD 16:2 LCD. On this LCD we are going to display the motor speed and nothing but set speed. These two will be displayed on the LCD, and the output modules, another is like MOSFET. From here the MOSFET, this whole two circuits called as SEPIC converters. So based on the input signal from the potentiometer and the motor speed, the microcontroller start controlling the trigger pulses to these MOSFETs. These are two MOSFETs on the circuitry, and based on this output signal directly given to the inverter circuits, and from the inverter we are going to step up the voltage which is sufficient for the motor to run. So from here we are going to get around 240 volts of AC signal directly given to the AC induction motor. So let us see the connections. So here, as I said, so the 5 volts given to this one, so we are using the PIC microcontroller. This is the reset switch, potentiometer given at the A0 pin, and IR sensor given at the A4 pin, and LCD at B2 to B7, and the MOSFETs are C1 and C2 directly to the PIC 16F73 microcontroller. And here once a given signal given to this one, so based on the on and off pulses there will be two inductors and the two capacitors. They are working as charging and discharging. Based on that we'll get the boost of the voltages which is sufficient for the induction motor speed controlling. Based on by controlling the voltage we can control the speed of the induction motor, and after that given to this inverter circuits. So we are using the full bridge bridge rectifier, full bridge inverter circuits. So from here we are going to give the provide the pulses which is of 24 volts, and that voltage is directly given to the transformer step up pulses. That's 24 volts pulses given for the step up, and from here we are going to provide the same voltage from here, and this was used for the induction motor. So let us see the connectors. So like here I, so we should connect at this I point, and another battery. So is a B battery. So we need to connect the battery at this slots as shown in the same direction only. And next is inverter. So after the outputs, so this is the output directly. So O was mentioned here. Just connect that in the same direction, and then give the power supply to the motherboard, and you can see the welcome message on the LCD screen, and the set speed is 0 and the 0. So as I should mention, we discussed the flow, potentiometer and IR are the inputs. So when it rotates you can see the IR is on and off. So I am setting that. So you can hear the sound. Like this, okay, 72, and it will be locked up and down at the given inputs. So if I increase the speed, so the speed also will be increased continuously. If I decrease it 0, and it comes down to the 0. Thank you for watching demo.